Welcome everyone to my world, where we play Dungeons & Dragons in Minecraft with giant redstone machines. And if you stick around to the end of this episode, I'll show you how we built this. The beating heart of our redstone virtual tabletop. Hey there Yeti fans, welcome back to our Minecraft world where we build a playable Dungeons & Dragons game using redstone. Now in our previous episodes we created this world completely randomly, we gave it some lore and history, we created a world map, including this giant physical one that I'm standing in, and we spent multiple episodes creating an interactive redstone character creator, including this mountain-sized printing press for duplicating arcane spellbooks. We've been building for most of the last year this here character creator. We still need to do a little bit of decorating in, but that's not what we're going to be doing today. The point of this has always been to use those character sheets to play Dungeons & Dragons in a giant D&D machine. And that's the reason I'm standing over here on the future site of the machine itself. Because we're going to start designing this thing. Now this, I'm going to set your expectations here. This is going to be a process. We're going to be spending at least 2 or 3 episodes on this, I would say. So, here is the big problem I want to solve. We're going to have maybe like 4 to 7 players playing Dungeons & Dragons at the same time. I want every player to have something in front of them that they can use to make whatever D&D roll they want. And even if they all do it at roughly the same time, they're all going to get their rolls back and they're going to be able to see what they rolled and what everyone else rolled. So that's the goal for today. And I'm going to start not in our beautiful world here, but over here in our redstone testing world. Have I been testing a little bit of redstone in it, do we think? Maybe. Yeah. Some weeks and even months have been spent in preparation for even starting to do this. I want to bring you back to something we made a long time ago. Way back last year. This is the version of our dice roller. And I'm going to grab here like 3d8s and I'm going to throw them into the machine here. A 1, a 2, a 3. And this machine is doing a bunch of dice rolling, and then I'm going to grab myself a cart with a hopper in it and send it off. And I'm going to wait, and I'm going to wait some more, and still waiting. Cart is picking up the result of my dice roll, and hey, good. So I know that I rolled a 2, a 4, and a 7, and it rolled up to an 11, which is correct, but that was slow. And we're going to need to do a lot better. I would like it to be more like I roll 1, a 2, 3, 4, 5, 6, 7, 8, 9, 10. And then within, I mean, that was a fast 10 seconds, but within 10 seconds or so, we get ourselves a result. And that also brings us to how we're going to show that result. For those who didn't see this announcement, I created a data pack called Proclamations. Now, I'm a big fan of stuff that adds to the survival vanilla-ish experience. Like a good example is the audio player mod from Breadloaf and Henkelmax. You know, you're still playing survival Minecraft, but now you can create these immersive audio experiences that just adds another layer to your world. And there's data packs like Percy's Sewing Kit that lets you use custom models and item textures. So Proclamations is another tool in that toolkit, but it lets you use the Minecraft title command. So let me demonstrate here. So, in Proclamations, what you can do is you can enchant banners in an enchanting table. And if I was in survival, that would have taken some levels and some lapis. What it does is depending on what block you attach it to, it does different things. And what we want to use today is the thing that it does when you attach it to a block with an inventory, like this. So because it's attached to the side of this dropper, we're going to get these options. So what we want to do here is I'm going to show this to all the players who are logged in. I want to show player heads, and I'm going to show you this feature in a second. So inside this Shulker box, we have some special items. We have a player head. We have some different colored wool and carpet. And we have here a couple of item frames that have the names of sprites in my server resource pack. And what we're going to do here is put the Shulker in the dropper, and the minute the inventory changes, this here banner is going to go, oh, I need to show this title. And we can also configure it so that it'll show only to me, because that's my player head. This wouldn't show to anybody else who's on the server. So what we're gonna do, I'm gonna do one other thing here. So I'm gonna turn on display title in chat, and then as well as showing on the screen, we're gonna get a log of what all of the messages were, which is good because we want to be able to look back and see what we rolled because it's only up for a couple of seconds. We want to be able to see, oh yeah, what did I roll like 10 seconds ago? Okay, so here's my problem. I mentioned earlier I wanted this to be quick. Well, let's imagine I want to get 20 white wool into this Shulker, because what I've done is I've just rolled a 20 on a die. And the reason I want to do that is, let's get a barrel here with the Proclamations banner on it. Now, what I want to do is put that 20 wool in there, and then that's going to be my roll result. 20. But let's try actually putting 20 white wool into this Shulker here. And if you see how long this takes, this is an item every 8 game ticks, or only 2.5 items per second. So that's 8 seconds just putting the items in the Shulker. And that is no good, because it's not just going to be these 20 items. So we have that 10-second budget for all of our redstone. And if we use up 8 of it just filling this Shulker, that is not going to fly. So we need to be faster. And we can be faster with droppers. So let's say we have a dropper facing into this. And let me get a couple of observers. Okay, so same 20 white wool. This is twice as fast as hoppers. So that's got down to 4 seconds. But you see, this thing has more than one side, so we can do better than that. We can let's grab a copy of this. So what I can do now is I can pause the game, and then I can split up this and put 5 of each of these into these 4 separate droppers. And now if I unpause again, there we are. You'll see this is 8 times faster. That did the whole thing in 1 second. And this is about the physical limit, because we have 6 sides available to us, and we need the other 2 for placing the Shulker in the first place, and then we also need to be able to break it and collect it in a hopper. What I want to try and do here is I want to have our dispenser facing down. Actually, let's put that there and then have a button on top. And here's the magic trick. So I'm going to put a sticky piston here, and then any movable block that I have on top of the sticky piston is going to break the Shulker box. And this does work. But what we want to do is we want to be able to collect this. And here's one way we could do it. We put a rail on there, and then we have a hopper minecart. And you see that still doesn't quite work, because this is more than one full block. hitbox wise above where the hover minecart is. However, put some rails on there. The rails are still enough to break it, and look, it's exactly one block higher than the minecart, and that means that this is high enough to be able to actually see and suck up the shulkers. So we need to trigger these droppers, and we're going to do it with observers and rails. And now what I can do is I can power either 1, 2, 3, or 4 of these rails. So let's fill these full of wool. And now what I want to do is let's have a redstone line, and we want to make this a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This should be here. So this, if I light this one up, all 4 of these is going to reach just to the end. But then sometimes I want to be able to reach just 3, 2, or 1. So I do this one. You see only this line here lights up, and we get 1. This we should get 2, and this we should get 3, and this we should get 4. So now here's the challenge. How do I convert the numbers 1 through 20 into something that can be inserted with this controller? So let's come into our tavern, and we're going to find some space to do some new mathematics. Actually, maybe in the back garden here. Hello, skeleton horses. So, oh, hello, Allays. Hello, turtle. You see all of the menagerie that I've been collecting. So what I've done here is I have translated all of my numbers from 1 to 20 into a base 4 counting system. This is called quaternary, a little bit like binary is counting with 2. This is counting with 4. So my 1 is 0 times 4 plus 1. Then going all the way up to 2, 3, and then 4 is 1 4 plus 0. And then we have 5 is 1 times 4 plus 1. And you can see all the way up to 20. So we can encode all of our numbers using a certain number of 4s and a certain number of units. But we're not going to do it exactly like this because these are wasteful. So take 20 here. What I want to do is I want to fill my shulker box in as few ticks as possible. And let's say that I have... So I have 6 cycles that I've got to do. They take 4 redstone ticks each in order to fill my shulker box here. So I pulse the line that activates all 4 droppers 5 times. And then I have the phase where I do my units, and that activates 0 droppers. Now, that last phase, that is a waste, because it does nothing. We can re-express each of these by not ever using zeros in our units column. And we can do this one as 4 times 4 plus 4. This one as 3 times 4 plus 4. This one, 12, as 2 times 4 plus 4. This one, 8, as 1 times 4 plus 4. And this one here, 4, this is just 0 times 4 plus 4. Now this counting system is called bijective quaternary. It has a name. Okay, the first thing I want to do here is compactify this and give myself a bit more room to work with. Let's check this. So this one here should be 1. This one here, 2. This one should be 3. And this one should be all 4. Great. So I can get rid of this here and then mirror it on the other side for the 4's input. Okay, so this here is a comparator pulse extender, and this is set so that it loses 1 signal strength every time it goes through the cycle, and there's 1, 2, 3, 4 game ticks every time the signal travels. So we should see is every 4 game ticks, so every 0.2 seconds, the signal strength will go down by 1. And every 4 game ticks is great because, let's grab ourselves an observer, some dust here, and so what should happen is, that's exactly the speed that a dropper fires at. So I want this thing to fire twice. I can give it a signal strength of 1. I want it to fire 3 times. I give it 2. I want it to fire 4 times. I give it a signal strength of 3. Okay, you should be able to hear this working now. So this should activate all of the droppers 4, 3, 2, and 1 times. So let's try 4, 3, 2, and 1. And see, this one just bypasses the pulse extender. So if we think about how we would encode, for example, 19, that would be 4 4s plus 3. So 4 times 4 plus 3 is equal to, there we go, 19 mil. So what we're going to do here is we're going to use rails to send our signals from the dice rollers through the decoders. So what I want is when this torch turns on and off, it's going to pulse that line. Now you see it doesn't quite reach. We're going to solve that in a second. So what we're going to do here, I've shown you these before, I believe. What we're going to use here are budlines, or rail block update detectors. So this is a rail that, because of some shortcuts in how rails are implemented in the code, they stay powered when technically they shouldn't be. And when they get a block update, they realize they shouldn't be powered. And this little contraption that I'm building here, it reacts to the rails turning off and then puts it right back in that budded state again. And the advantage of doing that is normally rail updates will only propagate for 8 blocks in any direction. But when a rail realizes it shouldn't be powered, it creates a chain of block updates that can go infinitely far in a single tick. Okay, here's what we want to do here. We want to be able to take a redstone signal strength. So let's say we get a signal strength of 10. And then we want to be able to convert it into 10 white wool that end up in the Shulker box. So what we want to do is, let's say that this is the line here that represents 10. What we want to do is grab a couple of observers, and we know that we need 2 4s and we need 2. So, okay, so when I press this button, hopefully I should get 10 wool. Yeah, there we go. So this is a slice of a signal strength decoder. I just need to stack this 10 times. And then we feed a signal in using these 2 comparators, so that the signal strength at the top is going to be 1 less than the signal strength at the bottom. And to test, we're going to feed a signal strength of 10 into it. And you'll see what happens is we get exactly the 10th one, the 10th torch lighting up. So let's try it with a different signal strength. Let's try strength 5. And here you see I have the 5th one lighting up. So what I got to do is I've just got to stack this here. So here's how we're going to encode this. So we're going to start with 1. And in 1, we're going to have just 1 in the units column. So the 1s are over here. And then we're actually going to have 0 in the 4s column. And I've added this extra line here because we do want to keep track of that. So the system's going to need to know when it's finished processing the 4s. So we do need a 0 line. This tells it basically there's no 4s to process, you're done. Okay, and then what we need to do is, for our first 4, these are all going to be 0. And then we have a 1, 2, 3, and 4. And then that pattern's just going to repeat, except we're going to have our 1s in the 4 column here. And then again, where are we? A 1, a 2, a 3, a 4, And then I've added another 10 lines here on the right hand side because these are going to be 11 through 20. So because we can only have a signal strength of up to 15 for our D20, we need to represent it as two different redstone lines. 1 to 10 we go this way, 11 to 20 we use this line instead. So now I want to turn our attention to another feature. So if you look at these 4 droppers here, these don't quite meet our requirements, because if you remember what we were trying to do with the Shulker boxes, what we were trying to do is this, or something like it, where we know what roll we're making and we know the die rolls that went into it. Now, so we can't just have the total. So we need each of those individual lines back there to insert a different item into that Shulker box. So we're going to have to do something different with one of our 4 droppers here. So we're going to replace it with a line of droppers, and we're also going to have to do something special, because if we had to wait 4 game ticks for each item to go through all of these droppers, that would take a very long time. So we're going to use our instant dropper lines. If you've been watching for a while, you'll have seen these before. Yeah, so these take advantage of Redstone update order. And they go somewhat like this. And actually what we want to do is, let's grab ourselves a note block here. What I think we want to do is, when we start processing a die roll, we're just going to pulse this line as often as we possibly can. Like this. So if I do this, and then I go and put in, like, I don't know, 10 items here, they should start disappearing, and before I can even get there, they'll probably end up, down here. So, okay, then we have a button here that does start conveyor, then we have a button here that does stop conveyor. And now what we can do is we can go down here, and when each of these activates here, we can also get it to spit an item out of this dropper. So let's just copy all these. So what we're going to do is, let's have that dropper move to here, facing down, and then let's just do this. So the conveyor is turned on, and let's go practice rolling a 17. So it should already have inserted that item frame into the conveyor that's going to display as a sprite in our title. And we should also have our 17 white wool in there. So let's see what happened. Perfect. That's exactly what it should look like. Okay, folks, we have expanded this a little bit. I told you it was going to be helpful that we didn't have any sort of distance limit with these buses here. So just to show you what we've got here, this has enabled us to have different modules for all of our different kinds of dice, which is good because we have different icons that we want to display in the title, depending on what people rolled. So I've moved the D20 all the way down to here. This is that. And then this one here, this is another copy of the D20, but you see there are no observers up here. So this one doesn't emit any wool into the shulker. The reason for that is what we want to do. You see, we have these ones here that have BW at the end. That means these ones are black and white and crossed out, because what these are is, this is when you roll advantage or disadvantage. This is the roll that didn't count. So if you roll advantage, it's the lower one, because it's fun to see what you could have got if you if you weren't rolling with advantage. Always nice to know about those natural ones that you missed. Okay, and then we have the D4, 6, 8, 10 and 12, and I've left some room here for 2 more things that we need, which is positive modifiers, because sometimes you need to roll, say, 2d4 plus 4, and here negative modifiers, and that's going to be an interesting engineering challenge. So what I think I'm going to do now is add our dice rollers, but we need to do a little bit of an upgrade, because the old designs use a lot of comparators, and those I mean, it's not like they're super slow, but every comparator takes 2 game ticks, so that's 0.1 seconds. And if you have a lot of them in a row, and if you're rolling a lot of dice, that's going to add up. We can do a thing to speed up comparators. So for those who don't know, so you see our comparators here, they normally take 2 ticks each to update. But we can trick the game into updating them instantly by giving a block update to the side of the comparator at the right time. Bam. And I can show you this more clearly if I freeze the game. Those observers are firing in this tick, and all those comparators are updating in the same tick. So if you didn't see it in a previous episode, our dice rollers work by randomly dispensing one of a number of shulker boxes, each of which has a different signal strength. And I'm going to try and get the comparators in them to update instantly as soon as the shulker is dispensed. Ooh, hello. Okay, this is amazing. Okay. So I've done some optimization, and here's a side-by-side comparison. This is the old one. So let's freeze this, and so that's our initial input delay. So how many ticks is this going to take? It's going to take 2, 4, 6 things are dispensed, 8, 10, 12, and we get an output on 14 ticks. So that is, it's 0.7 seconds. This one here, that's our initial input delay, and then 2, 4, 6, it's done. 0.3 seconds. That is over twice as quick. This is why you optimize stuff, people. Okay, so let's just roll one of each of these and we'll do it real quick. Let's do 12, 10, 8, 6, 4, and we're going to go press the button and see what we got. There we go, total of 19. I think that adds up. Cool. Okay, now it's time to tackle the absolute elephant in the room. This is going to be maybe the most complex part of this machine, the D20. And not just, it's even going to be more complicated than the D20 that we designed last time, because this one needs to do advantage and disadvantage. It's going to be fun. So I made a machine. This is the D20. I guess you'd like me to explain how it works, huh? No? Okay. I have to chicken out here. There's absolutely no way that I can go through in detail and explain exactly how this thing works, except to say, this part on the top, everything's fine. It's normal. What this machine is doing is this is rolling 2 D20, 20-sided dice. There's a left one and a right one. And it is also capable of rolling advantage or disadvantage. So advantage is when you roll 2 dice and you choose the higher. Disadvantage is when you roll 2 and you choose the lower. So our advantage or disadvantage input is over here. So roll advantage, then we have this line lit up here. We roll disadvantage, we have this line lit up here. Now, let's roll with advantage here. So again, because we need to represent a 1 through 20 as 2 different redstone lines, because we can only have up to signal strength 15, we have our high or low. So we're adding up all of these numbers. Think of it this way. So here we roll a 0 or 10. Down here, we have a double roller where we roll 1 through 5. And here we have one where we roll 0 or 5. roll all of those independently, add them up, you'll get a 1 through 20. But then what we're doing is we're actually comparing these two results on the top. So if you pick randomly this purple one here, then this will be treated as an 11 through 20. If you pick this one, then it will be treated as a 1 through 10. Now the rest of this machine here, what it's doing is it's comparing these two results, and then it's seeing which one is higher or lower, and then if we're rolling advantage or disadvantage, it picks whether to flip them or not. So our outputs for these machines are these 4 lines, these 2 bluey ones and these 2 pink purpley ones. Now the blue one and the pink one go to the right. These are the ones that are treated as the actual result. The other ones here, the cyan and the magenta, this is the roll that didn't count. So if we're rolling advantage, the higher one here is always on the right, and the lower one is always on the left. And that means that of these two outputs, we always want the higher one to be on the top, the lower one to be on the bottom. And then if these happen to be equal, we also need to make sure that the higher one of these two is on the top and the lower one of these two is on the bottom. So in order to route these two dice outputs to either the top or the bottom, we have this arrangement here where we're feeding this into both the top and the bottom, and then we're suppressing one of them. So you see on the left hand here, we're suppressing the top output, and on this right hand side, we're suppressing the bottom output. And then if we want to, we can flip these. So if this yellow line here is active, these will invert. This one will turn off, this one will turn on, and vice versa. And then what we're doing here is we are comparing the left and the right die. So the left line here is the blue, the right is the orange. We're comparing them to each other. So this one here, this comparator, turns on if blue is higher than orange. This one turns on if orange is higher than blue. And then they go down to these green lines here. And then if we're rolling advantage, which we are here, then we flip our outputs if this one is high, which is why this one is currently enabled. If I go over here and I decide to roll disadvantage, then now it's going to choose this one instead. It's going to flip if this left one is high. Again, if the yellow line is active, that's what flips the two dice. You see, this feeds the yellow line here. And then we have a similar arrangement down here. Again, we're comparing the two. And then we also have them connected here, because whether we flip the bottom two depends on whether we decided we needed to flip the top two. And finally, we have a mode here where we can just roll one die, which actually most of the time people are just going to want to roll 1d20. So this button here, this sets the yellow line to permanently on whatever happens. And what that does is it means it's always going to flip them. It's always going to send the left die to the right output, which counts. It's always going to send the right die to the left output, which gets discarded. And then we're only going to roll the left die. The right die is just going to have a signal strength of 0. What I'm going to do here is I'm going to demonstrate. So this is our I'm done line. I have this temporarily hooked up here, so it's just going to, whenever we roll a d20, it's just going to output the result. So first off, we're going to activate our take first roll button there, and then we're going to use this one here, which is only going to reach as far as this observer, and it's only going to roll the left hand die. Okay, we got a 4. And a 14. A 6. So this is a high one. Another 14. Okay, now let's try rolling with advantage. You'll see when I hit this button, it's going to reset that toggle there. So now we're rolling with advantage, and we're going to roll both these at once. Okay, 13. Natural 20! Okay, and then finally disadvantage. See if we can roll a natural 1. Oh, yeah, there it is, a natural 1. I summoned it. Okay, now I've made a start here on our static modifiers. So we have the positive ones here, starting from +1 all the way up to +9. And these are very straightforward. These are just literally encoded like the others, and all we're doing is just providing a single tick pulse. So to trigger these, you're just going to have an item in your Shulker box that does the roll called a +1 or a +5, and they're going to be 9 different items. They trigger 9 different lines, which is why they're kind of stacked like this, so that I have room so that they don't interfere with each other. Similarly, we have 5 different items for our negative modifiers. We're probably never going to need more than a -5. And I do have an idea for how I'm going to do this. So I did think about, like, can I do something to prevent the wool, that number of wool, say we use a -5, can we prevent 5 wool from going into the Shulker? That is tricky to do. I can't really think of a good way of doing that, but what I can think of is a way to suck the items out of the Shulker once they're in there. Now, doing this with hoppers would be very slow, as we've determined. Hoppers are about the slowest way of doing anything with items. However, one thing I can show is that these rails stay intact even if they're attached to something. So we can actually use this to send in something that is way quicker, a hopper minecart. If you don't know, hopper minecarts are 8 times faster than regular hoppers. They pull items out of Shulkers at a rate of 1 per game tick. So what we're going to do here is, let's put some droppers here. We're going to fill these absolutely full of wool. And the hoppers. Let's stack that. Okay. And now what we can do is let's get some rails again. Okay, so here's what we're going to do. Let's unpower that for a second. We're going to put a hopper minecart here. We're going to have it completely full of wool. And then let's send imagine what would happen if we activate all of these. We've just lost 5 items out of there. And that is going to create 5 items worth of gaps in these hoppers. Which when I run this over the top, here's what's going to happen. So we want this to have 11 at the end. So that's exactly what's happened. And then if I were to activate, let's say just 3 of them, this is going to suck out 3 more items out of here. There we go. So what we can do is we can hook this up so that this one here is going to give this the max signal strength. So what we want is, let's power that, and then we want this to get just to the end. Okay, we need a little bit more. Probably another 2 like this. Okay, so that gets just to the end. So this is our -5, and then this here should be our and then this here should be our -1. Yeah, and this activates just one of them. Okay, now we have one more edge case we need to worry about, which is this. So let's say that we have a shulker here, and oops. So let's say we have a shulker here, and this has 4 wool in it, and we do a -5. What's going to happen is this is going to keep going forever, because you can't actually have a negative number of wool, because negative numbers aren't real. You can trust me, I'm a mathematician. So here is what we need to do, I think. Let me stop this going for a second. So what I need is for there to be a fallback where we can refill this minecart. So this should be refilling. There it is, slowly. Okay, so if it's short a couple, it will eventually fill up from here. However, we don't want this to be active all of the time. So first off, let me just put a barrel up here, which is full of wool, as a buffer to restock this. Let's put that back. And then what we want to do is we want to lock this hopper most of the time. So we only want to unlock this after I think we get the signal to eject the shulker. We leave this unlocked for a while. Now that we have our dice rollers, the next thing that we need to do is to give our players a nice user interface that they can use to make any dice rolls. And that means adding up multiple different kinds of dice, adding bonuses, and also one other feature that I want to have. So this is what I think a typical roll is going to look like. So in this case, we have a d20 rolled with advantage. We have 3 static bonuses, 1 + 3 and 2 + 2s. And one thing I want players to be able to do is to choose whether their rolls appear publicly on everybody's screen, whether it's just them and the GM, the person who's running the game, or whether it's only seen by them. And then finally, we might have a description for what kind of roll it is that appears in the title. And right at the start, we have the player head, so we know whose roll it is. So every player is going to need a stack of player heads, which are going to be recycled and returned to them. Now, what we can't do is have all of these sitting in a shulker and then we just pull one item out at a time in a hopper. One of the reasons we can't do that is that we're going to need to sort the items. The fastest way to do that is with one of these water stream sorters, but even this, the items in it only move at a few blocks per second, and it's going to be, there's something like 20 different items we need to sort, so it's going to be at least 20 blocks long. So what I want to do is sort all of the items in advance and do them as quickly as possible while other items are being processed in the machine. And then I want to store them in a way where we can call them up in like a few milliseconds. So we are going to need a way to really quickly pull all of the items out of one of these boxes. And now, one way we could do that, so if we try and do it with a regular hopper, you'll see this pretty slow. As we've determined, we basically never want to use hoppers for anything. But what we can do is we can use a hopper minecart now, and then we put our items into a regular sorter. Now this thing here, we have 4 hoppers here. This can go at 4 times hopper speed, obviously. Now there is a drawback with this kind of setup, which I'm going to show you here. Imagine I've just dispensed this shulker box. Now the good news is that got emptied pretty quickly. Okay, look what happened here. So this is not foolproof. These hoppers have a cooldown. They can only suck up certain numbers of item stacks, and eventually they can get overwhelmed. And so this isn't quite safe. What we want to do is we want to make sure that that these can keep up. Now, there is a different kind of sorter we could use, which uses these hopper minecarts. However, I'm just going to show you what happens here. So, the good news is everything gets sorted except the unsortable items. But they don't end up down here, because the trouble with this thing is it sorts typically 8 items at a time, I think, or maybe even 16. So when I get this up to a certain level, yeah, I get it up to over 41. It's gonna trigger, and then a whole bunch of them are gonna drain out at once, and that is no good because we need to count the exact number. However, we do have one more crude and extremely fast alternative, and that goes somewhat like this. There we go. Burn it with lava, and all of the items will be dropped out in their complete stacks. That is the fastest way of that you can possibly do this. But it's going to get a little bit expensive in Shulkers. The good news is, for the Shulker shells, I do have this machine, which I've already built here in the world. But Shulker boxes do require wood, and so far, this is my bamboo farm, and this is the best way that I have of getting chests. Yeah, I think it's time for a quick side quest to upgrade this. Okay, folks, I've done a little bit of designing. Oh, well, when I say designing, I mean I've taken Izuma's bamboo farm and scaled it up. And when I say I've scaled it up, I mean I've scaled it up a lot. So what I'm going to be doing for a while, this is going to take several days, I'm going to dig out underneath this hill, and after one quick jump cut, or from my perspective, many hours of digging and building, I've done 3 out of 9 layers of this here bamboo farm, and that might be enough for now. Actually, I haven't checked. It might be enough to keep up with the output of the Shulker farm anyway. I kind of do want to eventually bring it all the way down to bedrock, just because. But under my feet here is deep slate, and that's going to take even longer to dig out. So, we'll go all the way down to bedrock eventually, because, a grindy project can be fun while you're doing other stuff. But this should do for now. And if we're going to look at the output of the thing, you can see it ticking up there. This does not take long to fill up a whole shulker full of bamboo blocks. So I will have chests for days. So we're going to burn a shulker box with lava for every roll we make in our games. Well, that's a flex. So I'm going to design a machine to do it. So I'm going to need a dispenser on one side for the lava. And I'm going to need a dropper on the other side for our shulkers. And let's just cut this off here. And also grab a trapdoor. Because what I don't want... I'll show you what I don't want to happen. Which is that we accidentally leave the lava out for too long and end up making stone. So let's avoid that by having a waterlogged block. Is it best to have it? Yeah, it probably is still best to have it this way. I think things could get stuck on that lip. Okay. So now, let's put this here. Yeah, now even if we accidentally leave that out for too long, it can't create any stone. So yeah, one thing we can do is that when we get that initial activation, we're going to push that rail out of the way. And then also, the added benefit of this is that when we get another item in here, if this item arrives, if this shulker arrives when we're still processing items in our roller, then it can wait in here until we have a signal that comes back saying that it's safe to push our rail back. Okay, so imagine we have a few of these in here. The first one there gets dispensed, and then this is waiting to be told that it's ready for the next one. Okay, perfect. That is as quick as you're ever going to get. So now we can have items in here. And this also activates this line, which is a nice bonus in case there happens to be anything stuck in here. It should automatically be sucked all the way into the end here. So you've probably all seen more of these before. 1, 2, 3, and another one. Then 1, 2, and one of these. And that, and that. And then we need a comparator. Now here's what I want to do. I want to have, when our items get picked up by our sorters, we're going to get them arriving in these droppers. So I need to indicate, let's do it this way actually. So when this has an item in it, so what we want to do when this happens is we want to pulse this dropper so that it spits out the block and then it counts as processed. So let's do some observers. And what I actually want to do, I think, here is move these. Let's move that to there. Let's move this up. And then let's move all of this up. And now what we can do is we can power this block and do it like this, and then we just need a block that we can put in between. We can't use a note block or a redstone lamp because they're solid blocks and they'll propagate the update to the one next to them as well. But what we can use is a copper bulb. Okay, there we go. So yeah, you can see that's retracted now. Now we're only going to be able to repeat this. We can't stack, we have to clone. We're only going to be able to repeat this slice once every 2 because we have to have this sawtooth pattern here. So let's just verify that it works. Put a redstone dust in this one and in this one. So those are both waiting to be processed. And let's just do it with a button here. Oh yeah, okay. It's got to be a short pulse. Let's do that one more time. So 1 redstone dust in here, 1 redstone dust in here. So imagine these are dice items waiting to be processed. Yeah, so that one's now being processed, and then the loop comes back around, and then we process the next one. Okay, so that's only once every 2. But what I think we can do, so I don't copy air here. What I think we can do is let's clone all of this and rotate it. And I think we can just interleave these, and I don't think they'll interfere. Okay, I've compacted this a little bit so it's a bit slimmer, and then I've also added these quite complex instant repeaters. This is we saw the instant repeater earlier. This is an instant repeater that gives a 2 game tick pulse, so a 1 redstone tick pulse output. So you can see that they are redstone on that sawtooth pattern at the bottom. That updates instantly for the whole machine. Editing Mojo here. What if I were to tell you that the really overcomplicated 1-tick instant redstone repeaters that I showed you were really overcomplicated? So, here's the problem I was trying to solve. The problem is, this is a... Oh, I'm going to show you the lever. This is an instant repeater. You can see, even if you like pause the video and like boop, you'll see that these 2 redstone lines, the input and the output, turn on at the same time. However, sticky pistons, which this is, have a problem, which is you give them a 1-tick pulse, and then they spit out their block, and then this is on forever, and then it's a disaster, and then we've created a T flip-flop, which is really useful to have an instant T flip-flop. Not what we're going for here. So I overcomplicated this problem here, and then I had things going at the back of this thing that would repeat it, and so I was like, hey, like, let's have a 1-tick delay and then a repeater going into this thing that's then going to activate this thing, and then it's going to pull its block back, and then, well, okay, the output's now 2 ticks, so we're going to put another piston here that's going to cut off the thing. When you don't need to know all that, because here's a better solution. Okay, let's do this, and then this, and problem solved. 1-tick pulse instant repeater. I just gotta, okay, when you see this machine, just assume that there are these everywhere, because this is gonna... It's everywhere I put those monsters before. This is a better solution. I'll go through and replace them with these before it actually gets built in the world. Okay, editing Mojo out. Yep. So what we'll need to do next is we'll need to put in some instant rail budlines for each of these. And the good thing about them being 2 apart, each of these, is they're not going to interfere with each other. But some of them are going to have to loop back under the thing so that we've got 2 layers. So I've done some wiring. Look at my domain. I'm going to build this in survival. How crazy is that going to be? So we have these crazy budlines coming up, and I've wired them up so that they all pulse the correct inputs. So we have our regular D20 here, and we have our D20 with advantage here, and we have our D20 with disadvantage here. They're all wired up to the correct bits. Then peeling off here, so everything on the bottom is everything on the bottom is the dice, or at least everything up to here. So here we have our D4, 6, and 8. Here we have our D10 and D12, which are wired up to the top. And then all of this spaghetti here, these are our positive static modifiers, and these are our negative ones. Also, I've put in 2 additional lines here. This one here is the I'm done processing all of the dice line. And what it does is it goes all the way down to this processor here. And then it basically the thing happens where it checks whether this is still running, and if it is, it waits, and then when it's done, what it does, it'll eject the shulker, and it'll also send a signal back saying I'm really done. And then this is what is gonna ask for the next shulker. And then there is one other line, which is when we light this up, it is also going to start the conveyor. So here's the process. Let's grab. Let's use the one that we've been using as an example. So here's the process. We start processing, and then that comes over here and starts the conveyor. So you can see that the conveyor is currently running. Oh, and hello, it worked. Way quicker than I can explain it. I would have to slow down time quite a lot. Yeah, so this starts the conveyor, and then this is running through all of the dice that it processed into these filters. What it's doing is it is lighting up these bud lines one at a time, whether it's updating these bud lines one at a time. And then when each of these machines has finished doing its job, they pulse this bud line, which then comes back and then asks for the next one. And then when they're all done, it comes all the way up here and fires this line. Then that tells the processor down there that it can eject the shulker when it's ready. And then we finally get it to come up and ask for the next one. Okay, now what's left? So one thing we still need to do is we still need to handle these. So we're actually going to need, instead of this one different banner, we're going to have 3 different ones for 3 different configurations that the shulker can go into. So I need to build something here to do that. The other thing we're going to need to do is, hey, look, lots of junk in here. We're going to need a system to recycle all of that. I knew I was forgetting something. We're also going to need to deal with this. So all of these items, we need these to end up in the output shulker as well. So what I'm going to try and do here is squeeze this line in somewhere here. And I'm just going to have this be an extension to the conveyor. And fitting this in is going to be interesting, particularly seeing as getting dropper lines, getting instant dropper lines to face downwards is really challenging. Okay, so I have come up with a design that does the job. Let's go and trigger this one from here. So doing upward dropper lines is challenging. Doing horizontal ones is really easy. Doing downward ones, this is the first time I've ever been able to actually get it to work. But hey, so this is these rails are updating all of these droppers in precisely the correct sequence. But this could actually go as high as you want, I think, which is neat because I might need to do that elsewhere in this machine. And I have already, through a lot of careful moving of stuff, I had to bend some of these out of the way. But I have managed to fit this in here. So if I give myself another player head there, and I'm going to come and activate it from down, where is it? Here? No. Here. What we should see is, hey, player head there. So when we activate our conveyor, this is just part of the conveyor as well. Anything that goes in here will end up in a few ticks inside our shulker. So let's try that again, actually. Okay, there we are. Everything should have gone. Yay! Okay, there we go. So we have the interesting. We didn't get the die roll. Might need to debug that a little bit, but we did get the player head and the description of the roll. Okay, so now what I need to do here is, instead of having this one hopper minecart that's sat on this one hopper, I need to have a couple of additional options. So what I need to do here is, one thing I'm going to have to do is I'm going to have to get rid of the rails that's on, and I'm actually going to have to put down carpet, because what I got to do is I got to position the minecart so that it is almost entirely under here, but enough overlapping these two hoppers so that anything that goes in will end up in there. Now, what we can do is we can make sure that we have two of these locked at all times. And what we're going to do, I think, is then this one can come round and be like this. Okay, and then what we can do is we can have an array that is gonna remember which one of these will last pulsed. Yeah, you'll see what I mean. There we are. I haven't used any cauldrons yet in this contraption. So what I want to do here is, let's go up a few blocks, and then put some pistons in here. And let's just extend these for the moment. Then what I want to do is I want a circuit that will, it'll push down one, while, let's say I come and toggle this one. What it's going to do is it's going to simultaneously push down this one and then immediately push all the others back up. And leave just that one toggled off, which is what we want. And what we're going to do is, I think, trigger these with observers. Like so, like so, and like so. So let's see if that works. Okay, good. Okay, so far so good. Then this last one. Okay, that's doing what it's supposed to. Good. And here we go. These are now all hooked up. So this rail turning on here, this one here, this should be sufficient to update these lines. And then they're going to come and they're going to fire these observers. I've also figured out how to implement the 3 different types of roll visibility. So let me show you them here. So this one here, this is the public one. So I've got, to demonstrate, I've got 2 roll results. One with my head in it, and one with my good friend Lucy. And you'll see, if I put them both in here, you will see both of them get shown to me because they're both public. Let me grab those again. Now, this one here, this one is set to triggering player only. So if I put mine in, it'll show it to me. But if I put Lucy's in, nothing. But then this one here is the Whisper to GM one. And you'll see this has got a sorter on it. Well, it's not exactly a sorter. What this is doing is it's holding this one item in here. But if I put a shulker box in here, it's going to let it flow through and leave this item in. And this item happens to be my player head. So if I put Lucy's in there, it will fall through and end up down here. But it will also show it to me. But that wouldn't show it to any other player except for me and Lucy. There. Okay, so this is going to be a whisper to GM roll, and then I should still see it. It's currently set to public, so we'll know if it updated correctly. Okay, here it goes. Okay, we saw it firing there. There we go. Okay, perfect. Okay, there's one other little cosmetic thing that I want to try and do. And it's kind of bothering me a little bit that if you've seen some of the roll results, the player head and the description of the roll will appear in a random order. And I kind of want the player head to appear as the first thing on the left-hand side. And there might be a way of doing this. Because normally I can't use an item sorter like this to sort player heads, because they will all have different profile data depending on whose they are. However, Allays will pick up if you give them any player head, they will pick up any player head and then throw it on the note block. So let's give that a go. And what I want to experiment with here is, can I put an allay in a minecart and still have it pick stuff up? There we go. Okay. So actually, well, let me check this first. So I'm going to throw in a player head. Okay, that works. Let me try my player head. Okay, fantastic. It does work. Okay, so here's what I want to try. I am going to put this guy in the water stream because I think the items should flow right by. And what I'm going to do here is I think that did work. Okay, amazing. Right. So what I can do then is I can grab a hopper. So what I can do is let's replace that here. Now when I make a roll, the player head should end up in this hopper, which it does. Great. So what I'm going to do is I'm going to make yet another extension to my conveyor, and I'm going to see if this is quick enough so that it ends up being the first item. The next thing that I've done here is I've added a whole bunch of plumbing. So I'm not going to go through all of this, but there is a Shulker unloader in here. And when we get our roll results out of... Yeah, they end up in here. When we get our roll results out of the machine, they will end up in the Shulker unloader, and then we put all of those items back. And I don't have like sorters in here. I just have... These hoppers are just full. So yeah, we're doing sorting by knowing that we're only going to have that many items. It makes sense. Okay, I've done a few little tweaks and optimizations off camera, so things might look a little different here and there, but there's one in particular that I want to show to you, which is down here. And it is this thing here. And if you have a keen eye for textures, you might know that these our jukeboxes. And I have some dice rolling noises. And that's not all. I also added some sound effects over the top of that when the machine starts up and when it shows you the results. Probably best if I just show you. So let's grab a die roll here. And oh, okay. When the players are on the surface, they won't hear all of this clicking because the machine will be some distance underground and this will be muted. It'll sound more like... let's do this actually. Go up in the sky. Okay, we go this far, we can't hear the machine anymore. Hey, natural 20. Okay, I think I'm going to make a few more variants of that, but just to keep the variety up. I'll do that off camera. The one other thing I want to do here is I've made myself, I randomly created with all of my dice and modifiers here and some player heads of friends who you might recognize. I randomly created 27 die rolls to fill up this chest. So we have copies of them here. And we're going to do ourselves a little test run. Enjoy!